Today, let's take a look at the York 16-SEER modulating heat pump system. It is a modulating system with 50 to 100% capacity. The matches are with ECM air handlers or gas furnaces. It is a regular 24-volt control, non-communicating system, which takes conventional thermostats, which are 3 heat, 2 cool, 24-volt thermostats. Looking at the condensing unit, the top left picture here, we have a built-in inverter disconnect to protect the inverter board and the compressor. Top center, we have a new interlaced coil. At the top right, we show a picture of the inverter control with the main diagnostics board mounted to the bottom of it. Bottom left is a picture again of that main control board, which has a diagnostic readout on it. Center lower picture, accumulator, and bottom right, the third service port, which on the York system will give us a true suction pressure whether we are in heat or in a cooling mode. On this screen, we see the inverter board, and it highlights the 3 LEDs on the board. Because there's high voltage involved on this system, make sure these 3 LEDs are off and then do some voltage readings to check the system to make sure it is not energized before ever working on this control board. On the right, we see that main control board highlighting where our 2 7-segment LCD readouts are for diagnostic and operation of this system. Whenever we're matching one of these up, we need to make sure we can get a proper airflow with the air handler that we're matched with this system. This particular one, we're going to look at a YHM 36 B21S matched with an AVC 36 CX21. With this match, we need to make sure we have a high fan speed of 1,125 cubic feet per minute. Our low medium fan speed should be 825 CFM per minute. We recommend using the full-blown variable speed, or what York calls the premium variable speed, to make sure we can match this system correctly. It can be matched with a regular X13 constant torque style air handler with some additional wiring, but you have to be real careful about the matchup on the airflow. Some of those are hard to get correctly. If they are not matched correctly, you could have humidity issues in the house. If the location where you're actually putting the system in, you don't have to worry about humidity. It's in a dry area. You're going to be fine either way without any problems. This particular matchup, if you notice, will give us a SEER rating of 17.25. Looking at our performance notes on this system, we are limited to an 80 equivalent length foot of piping separation on this system. This is because the different stages, we had to make sure we have oil return, or proper oil return, I should say, on all capacities. We are also limited to a 25-foot maximum vertical height change, up or down. Heating is good to minus 20 degrees. Cooling from 35 to 110 degrees Fahrenheit. When this system gets up to about 110 to 125 degrees, it may start getting too warm on the inverter control board, and it could start lowering capacity. If it gets above 125, it could actually shut the system down. Also, though, you notice the cooling is down to 35 degrees Fahrenheit. Basically, what this tells you, you do not need a low ambient kit to use cooling on this system. And altitude maximum of 6,500 feet. Now let's look at low voltage wiring on this system. On the left, we have a thermostat. Center, we have our indoor unit. And on the right, we have our outdoor unit. Our 24-volt wiring from the thermostat on common will go from the thermostat to the indoor unit to the outdoor unit. Our 24 volts hot will go from thermostat to the indoor to the outdoor. Our fan or G call will go from a thermostat to our indoor unit. Our O reversing valve call will go from our thermostat to our indoor to the outdoor. And Y1, our first call for compressor operation, will go from a thermostat to the indoor to the outdoor. This is pretty much standard wiring so far. From here, it changes. Our call for auxiliary heat from the thermostat, W, has to go to the outdoor board first. W1 out from the outdoor board will go to W1 at the air handler. W2 out will go from the outdoor board to the air handler. The reason for this is the inverter needs to know when the auxiliary heat is being energized so it can control it. The W1 out will be an immediate call during defrost or when the W coming from the thermostat is energized to the outdoor unit. The W2 out will be a 15-minute time delay after W1 is energized. Your Y2 from your thermostat needs to go to Y2 at the outdoor unit. The Y2 out from the outdoor goes back to Y2 on the indoor unit. This is what controls our fan speed for the higher stages of operation. With this system, we recommend the full-blown or premium variable speed motor to be used, mainly because homeowners have different comfort requirements based on the location, and if this is a high humidity area, which most of us are in, the full-blown variable speed gives us more control over this system. With a variable speed, you have the options to be able to customize it more for their comfort, such as you have the 4 optional settings available on the fan control board, which actually we're showing the B section or humid at the bottom here on the screen. This gives us a ramped up mode before we go to full fan speed on this system to help pull moisture out of the house. And also with this system, with the full-blown variable speed, we do have the option of adding a dehumidistat for even more humidity control in this system. This is our interface control board. Here we have a last error button where you can retrieve the last errors as long as you do not have a call on the system. We have our test pins down below, just like we did before for testing defrost and speeding up the time delays. We have a test mode, which we'll look at a little bit more in the next slide. We have a tricolor LED and our LCD readout for diagnostics and operation. We also have some configuration jumpers for hot heat pump and the defrost temperature. This particular system has a different defrost. It will actually work as a demand defrost until it sees it did not do a complete defrost. Then it can go to a time temperature mode for operation of defrost until it sees a good clean coil, and it will go back to a demand. It is known as an adaptive defrost system. Here we're going to look at charging this system. You notice highlighted down here we have the test mode. We have normal, N, L, low, medium, and high. In normal operation, this jumper will be between the 2 top pins for the normal position. Putting this system in, first thing we're going to do is calculate the charge needed, and we're going to weigh the charge in. We're going to check and confirm our indoor airflow, like we looked at in the previous screens. We're going to put this in time mode. For charging operation, you have to put the jumper between the lower 2 pins to lock everything into high mode. We're going to let it run and let the system stabilize. Then we're going to check our superheat and subcooling to see if we need to add or remove refrigerant. And after all this is done, don't forget to put the jumper back in the normal position for normal operation. Now, let's take a look at the readout on our main control board. If you notice up here at the top, we have a status fault light. Our tricolor LED is green, and we have a readout of C4. If you look at the chart on the door of the system, we have on green, C4 on the readout, tells us we're in fourth stage of cooling. Here we have an amber light with an H4. Looking at our chart, amber light on, H4 tells us we're in the fourth stage of heating. There are many faults on this system that will show up on this display. Example of one, here we have a red with a 6-0. Red solid with 6-0 tells us that an inverter is running hot and it is slowing the system down because of this heat. There's a lot more to this system. This is just a general overview of what it does. Thank you for your time today.